So, egg white contains several important proteins like ovalbumin, ovotransferrin, ovomucoid, and lysozyme. These proteins are valuable in food, health, and research industry. One simple and low-cost way to separate them is by using head-induced coagulation followed by centrifugation. In this method, the egg white is heated at 75 degrees Celsius at different pH levels, which is 5, 6, 7, and 8. This causes the protein to unfold and stick together, especially near their isoelectric point. The resulting solid protein clumps are then separated from the liquid by centrifugation.
The objective of this project is to isolate major egg white protein. Also, the second objective is to optimize process parameter for efficient protein separation, which is different pH 5 to 8 at 75 degrees Celsius. For the second objective, to compare manual separation, coagulation, and centrifugation technique with advanced instrumentation, which is differential scanning calorimeter (DSC). Average coagulation time of egg white at different pH level, which is pH 5, 6, 7, and 8, are recorded, and the graph has been plotted as below. Also, it reflects the complex interaction between protein denaturation and aggregation influenced by pH. This result align with the detailed protein behavior described in the literature, particularly in the study by Stefanova et al. 2021, which investigate the physicochemical and functional properties of egg white protein. For pH 5, the fastest coagulation time was observed, which is 3.24 minutes, that close to the isoelectric point of albumin, approximately 5.4 to 5.6. Also, at this pH, the net charge of the protein molecule is minimal, resulting in reduced electrostatic repulsion and facilitating rapid aggregation. According to the Kwang et al. 2021, the aggregation rate is higher at pH 5.5, opacity will up more rapidly near the isoelectric point. Thus, protein-protein interaction dominate, leading to faster coagulation. For the pH 6, slightly higher coagulation time at pH, which is 3.49, indicate that while electrostatic repulsion begins to increase as the protein carry more net charge, aggregation is still relatively efficient. Based on Kwang et al. 2021, that protein aggregation remains favorable up to pH 6, especially at higher protein concentration. Thus, the pace is marginally slower than at the isoelectric point. For pH 7, the coagulation time increased drastically to 12.14 minutes, which is slower. This is due to the significantly increased net negative charge on the protein molecules, which enhance the electrostatic repulsion and hinders aggregation, even though thermal denaturation still occurs. The study extended at, which is Kwang et al. 2021, explained that neutral pH denaturation based on protein-solver interaction prevail rather than protein-protein interaction, resulting in reduced aggregation efficiency and delayed gel formation. For the pH 8, coagulation time decreased again to 4.32 minutes, while protein are still highly charged and repulsive force remain significant. Alkaline condition promotes stronger unfolding of protein chains and facilitate involving reactive groups such as sulfhydryl and disulfide bonds. As described as at Chuang et al. 2021, thiol and aminos group are highly reactive, especially in alkaline media, supporting the formation of a calculated gel despite repulsion. Also, this result reflects the dual influence of pH on protein solubility and aggregation behavior. Near the isoelectric point, which is pH 5, aggregation is fast due to minimal charge repulsion. At neutral pH, increased solubility and strong repulsion between negatively charged delay coagulation. In alkaline condition, which is pH 8, chemical reactivity compensates for electrostatic repulsion, enabling faster gel formation than at pH 7. This behavior highlights the importance of electrostatic forces, molecular unfolding, and functional group interaction in the coagulation process. In this part, I will discuss about comparison between manual technique, which is manual coagulation, and centrifugation. Also, high-end instrument like differential scanning calorimetry (DSC). So, the advantage of manual technique is cost-effective and accessible with basic lab equipment like centrifuge and water bath. Also, practical for observing coagulation behavior under varying pH and temperature. Also, useful for preliminary protein isolation for small-scale optimization. But the disadvantage of is lack specificity, cannot distinguish between structural similar protein like albumin and basilin. Also, purity and identity of protein are not confirmed, relies on visual coagulation and pellet formation only, prone to inconsistent due to operator handling and external condition. Also, for the differential scanning calorimetry, is the advantage is accurately detect thermal denaturation temperature like overtransferring at 63 degrees Celsius, overbooming at 76 degrees Celsius, and enthalpy, allowing precise protein characterization. Also, it can reveal interaction in protein mixture and effect of pH on thermal behavior, adding for formulation design. It's applicable in quality control and optimization of industrial heat treatment. But the disadvantage is expensive equipment and technical expertise required. Not a preparative method, provide data but does not physical isolate protein. Longer analysis time per sample, not suitable for high throughput screening. So for the industrial application, industry prefer using high instrument like differential scanning calorimetry because they provide accurate, detailed and reliable data on protein behavior such as denaturation, temperature and stability. These instruments help ensure product quality, safety and consistency, which is essential in large-scale food production. Also, available for optimized processes and meeting regulatory standards. But manual technique like coagulation and centrifugation still relevant in certain situations. They are commonly used in academic settings, small-scale research or by business with limited resources. These methods are simple, low cost and useful for quickly observing how pH or temperature affect protein separation, especially during early stage testing or basic learning. So for the conclusion, experimental data clearly demonstrate that pH has a non-linear significant impact on the coagulation time of egg white protein. These findings are in strong agreement with protein chemistry principle outlined in the provide citation. The shortest coagulation time near the isoelectric point confirm the central role of protein charge and aggregation behavior, while deviation at neutral and alkaline pH highlight the balance between unfolding and intermolecular interaction.
That's all from me. Thank you for watching.